Hey, what's up, guys? My name is Saurabh, and this is my YouTube channel, Data Science Novice. So, if you are new to my YouTube channel, please do like and subscribe. Your efforts are massively appreciated. So, this is a recording of a live session that I took for one of my UK students. And in this session, I have talked about gradient descent and its Python implementation, and how, with the help of gradient descent, algorithm tries to correct the mistake, or you can say learn from the mistakes. This topic is one of the most important topic in AI because once you understand how gradient descent helps algorithm learns, then every other thing will be a cakewalk for you. So without any delay, let's get started.
Okay, so the thing that we are going to learn in this session is what is gradient descent, and then we will learn about shortcomings of gradient descent. And finally, when we have this idea about what is gradient descent and how it works, then we build a linear regression model using gradient descent. So earlier, what we did, we use sklearn library to build linear regression models, but we are going to build it from the scratch, like how we can do that. Okay, so the first thing is that how machine learning flow works. So first thing is that we need to know the problem statements. That is what is our problem statement. For example, if I talk about your college project, the problem statement is we need to have some kind of data on credit card score, and we need to generate some kind of algorithm that can predict the scorecard, or that can predict whether the person will default on the loan or not. Okay, so once we have the data problem statement, when we understand this problem, that what we have to do, what we have to do, the second part comes to the data acquisition. So data acquisition comes from your provider, your client. So in that case, the capital one is your client, and then you have to ask for the data. And once, I mean, the data process, once we have this data, what we do, we explore and visualize the data. And the reason being, why we do that because we want to understand the data. Once you have the data, you need to know what kind of data we are dealing with, that what kind of trend it follows. And why we do that, we want to understand that how the data is working, how the data is. So once we have this data explored and visualize, we go for the cleaning the data. So for cleaning the data, we need to understand the data. That comes from the exploring and visualization part. And in that case, in cleaning data techniques, we check for the data quality, that how is data, I mean, whether there are missing values, how many categorical column we have, how many numerical variable we have, and all that thing. So, and how many missing values we have, whether we have any outliers in the data, and all that thing. So once the data is clean, we go for the training algorithm. So we feed the training algorithm, in this case, linear regression or any kind of algorithm. It learns from the data, and it try to predict from the data. Okay, so once we have this training algorithm, we do the model evaluation. And how do we do that? We talked about the train and test split method. So we train the model on training algorithm, and we evaluate the model and test data. And and this process is very this process is, you can say, it is repetitive process. So in model evaluation, if we are not happy with the model, what we do, we go back to the data cleaning part, and we try different techniques. So for example, you try a missing value technique, then you are not happy with the result. What you did, you try the different technique for the missing values, and then you train the algorithm, and then you evaluate the model, right? And in between this thing, model evaluation and training, there comes the part of hyperparameter tuning, right? So if you think that the data cleaning pass, you have reached the limit of data cleaning part, like you cannot do more than this is the best data cleaning you have, what you do, you go for the hyperparameter tuning. You train the parameters of the algorithm. I mean, you look for different kind of parameters of the model. If I use this number rather than this number, what will happen, and all that kind of thing. So once we are happy with the model, that we are happy that the model is predicting right, we go for the deployment of model. So in this case, for example, you develop the model for the capital one, that you develop a model that can predict whether the person will default or not. So what they will do, they will use your model and they will deploy it, the model, and they will
Hmm.
use for further. So the actual use, when it comes to using the algorithm, I mean using the model is getting used when after deploying it. So it start predicting on the real world data. So this is the flow of the particular machine learning problem statement, or you can say project. Okay. So obviously we are
Okay.
not going to talk about this thing. We are going to talk about how algorithm learns. So this is a training ecosystem. Like here, so this part is expanded, right? So how we give the clean data to the algorithm. So the first thing what it does is it tries to predict. It tries to predict on its own. I mean, initially you do not have to give anything. It's just algorithm tries to predict. Then what happens is that it calculates the loss. So for example, if I take the loss, how we define the loss. So loss is nothing, just how much we are wrong or how much algorithm is wrong. For example, if suppose you are an algorithm and you are giving a test. So in the test, out of 10, you performed 5. So what is happening? You are predicting. You are predicting some answers, then you are calculating the loss. So you came to the conclusion that your answer, you are getting 5 marks, but you have to attain out of 10. That is the loss of 5 marks. Now what you do? You do the loss optimization. You try to minimize the loss. And how do we minimize the loss? We minimize the loss by changing the parameters of the algorithm. And this process keeps on repeating. Like you predict, then the loss calculation, then loss optimize using parameters of the model. Like in linear regression, we have alpha and beta are the parameters. So what algorithm does is it tries to change the value of alpha and beta and look for those values in which loss is minimum. And it keeps on repeating till the time we want, till the time we are happy with the predictions. So far, so good. You have any question on this? Hello? Hello?
No, Saurav. No, Saurav. It is good.
Okay, okay, good, good. Okay. So now, before going into the gradient descent, that what is gradient descent? This is the example that you are going to see everywhere. I mean, this is a very basic example, and it sets the intuition right for the gradient descent. So now what is happening here? You can see that this is a mountain and this is a person. And you can see that he does not have eye. And I did that deliberately. You can see that. Okay. So now he want to descend. He wants to go here. Now he can't see
Okay.
that, right? So what he has to do? Now, even if you imagine yourself that you can't see and you are on a mountain. So what first thing that you have to do? The first thing you will do is you need to have an intuition, right? Whether
Hmm.
where I'm standing has a steepness. Like if you're on a steep surface, you will feel that thing, right? I mean,
Hmm.
you can feel, even if you close the eyes, you will feel this thing that, yeah, there is a steepness, right?
Yes. Hmm.
So, first thing that you will ask you, the question is whether there is a steepness. Now, second thing you will ask that whether, second thing is that how you will ask that how much I should trust this intuition. So, the intuition that I am having, how much I trust it. Do I trust it or not? If I don't trust it, obviously you are not going to move, right? So before
Hmm.
moving, you check two things: whether I am standing on a steep surface or how much I should trust this feeling of steepness. So once you have checked these two things, what happens is you take the step, right? And
Hmm.
once you are here, what will happen? You will again ask the same two questions: whether I am standing on a steep surface and how much I trust it. Now these two things are checked again. You again take a step. Now you are here. Now again ask the same question. You are going to be here. You take the step. Then you take the step. Now, once you are here, what happens? You ask the question whether I am standing on the steep surface or not. And once you have this feeling that I am not on the steep surface, what you do? You are going to stop. Now you know that
Hmm.
you are in a you have descent, right? So let me show
Hmm.
you into this thing in a motion. So what happens? It we keeps on going, and once we reach the when the surface is flat, we stop. So two things that are important in the descent is intuition and the trust or faith in this intuition. So this keep this example in mind because this is going to help you understand what is happening.
Yeah, yeah.
So
It is too good.
yeah. So what is gradient descent? So the gradient descent is an optimization algorithm used to find the values of parameter of the function that minimize the cost function. Okay, so you know that it is a linear regression, right? So
Hmm.
for the time being, I am considering this linear regression problem that we have done. I mean, we have talked earlier about this linear
Hmm.
regression. So we know that the parameters are alpha and beta,
Hmm.
right? Now
Yeah.
we what we do, we make a prediction, right? Now we make a
Hmm.
prediction. So let me I think. So we know that so alpha beta, right? So this is our actual prediction, right? This is our actual prediction, and this is the prediction made by the algorithm. Obviously, there is going to be a difference between both of them, and that is known as loss,
Hmm.
right? So if you remember, we have done this thing as well. So this is the loss, and if you
Yes.
remember, this is called RSS.
Hmm. RSS,
Re-
residual error.
And if you divide it by n, the number of observation, it is known as
Hmm.
mean square error.
Mean square error.
Mean squared error. Okay. So if you see it here, so what happens is you we use this linear regression algorithm, and we predict something, and then we calculate the loss. Loss can be anything like mean squared error, residual sum of square. I mean, if you talk on broader level, the thing that they are do the same. I mean, when you go into the depth of how mean square error is different from residual sums of square, then we can talk about different aspect of how mean squared error is better, or RSS is better. So, but on the broader level, they both do the same thing. So once we have this mean square error, I mean, when we have the error quantified, what we do, we give it to the gradient descent, and it minimize it. And it minimize it how? It minimize it by changing the values of alpha and beta.
Alpha and beta.
In this case, because alpha betas are parameter, right?
Hmm.
So in this case, it is going to change the value of alpha beta. So suppose earlier the value of alpha is 2 or beta is 3, then it predicted something like kuch bhi, and then it calculated the loss. Okay. And then we give it to the gradient GD algorithm. What it going to do is it is going to look for the value. So suppose in next iteration, what it will do, it will check for 1.5 or 2.5, and the same process is going to repeat until we get the results, better result.
Hmm.
Okay, so this is how it works. Now next thing is that why we use gradient descent. I mean, earlier I showed you something like, if you remember, we can find the values of alpha and beta using if you remember, by differentiating, by
Differentiation.
by partial differentiation, we can find the values of alpha and beta. But
Hmm.
what gradient descent do is it tries to approximate. And why it can do that? Let me show you the example why we do that. So suppose these are two lost function. So let's look at the first. It will be end in 10 minutes. I will send you the link again. Okay.
Yep, sure.
Okay. So here you can see that, suppose this is our loss function. So x square plus 4x plus 4. This is some kind of loss function. And if we try to find the value of x, we can always find the value of x by using
Yeah,
differentiation, like
differentiation.
we used to do in 12th class or 12th
Hmm.
class or even college. So in this case, things are easy because the loss function is really simple. But on the other hand, look at the cost function second. So it is x ki power 23 plus 4x ki power 18 plus 4x. Now, if we try to differentiate this thing, you get this thing, right? But now, if
Yes.
I ask you to solve this problem, can you do that?
Mm.
I mean, you cannot do that. You cannot find the value by simply
Yes.
putting it equals to 0 because it is higher order polynomial
Mm.
and we
Oh.
do not have capability. So as the algorithms we do not have any analytical method to solve this problem. The only way is we can approximate it. And how we are going
Mm.
to approximate it? Using gradient descent. So here the
Gradient.
problem, so when the cost function get complex, we use gradient descent because it is
Okay.
easy to approximate in this case, right? So,
Okay.
okay, got it? Or you have any question?
Got it. Got it.
Okay. So, whenever someone asks you and whenever it is being asked, just the reason why we use gradient descent is it can easily approximate. I mean, there are many benefit of gradient descent. One of them is it is very simple. And second is it can approximate higher degree polynomial or higher degree cost function. Okay.
Okay.
So, okay. So next thing is that now let's see the algorithm. So how the algorithm is, the equation for algorithm. So suppose you are here, right? Like, like in the case of this person on the mountain, you can imagine that this is the mountain, the steepness, right? So the person
Mm.
is here and we have the equation for them. So the new position of the person is going to be the old position minus learning rate into the gradient. So now
Mm.
let's first talk about what is gradient. So gradient is nothing. If I try to compare it with the first example is the intuition. So in real life, we have this intuition like we have steepness. But when we go into the mathematics, how do we know that we have the steepness? It is by
Mm.
using gradient like dy over dx or by slope. So this is the slope. And what is slope? Here the slope is going to be the loss. Loss in terms of parameters. So how the loss is changing? I mean, how the loss is changing when we change the parameter. Okay. So here the
Okay.
here the person is standing and you can see that the steepness is going to be very high, right?
Mm.
So then this case is the gradient is going to have some value,
Mm.
right? So now the next thing is that faith. Now faith is again a new thing. It is called learning rate. In terms of in technical term, we call it learning rate. And with an example, you get more clarity on that how what is learning rate. So when we combine the learning rate with gradient, what we get? We get step, right? So
Okay.
here you can see that the step. And I will share the PPT with you so that you can go through the notes again and again. Okay.
Mm.
So once you combine the learning rate and the gradient, you get the step. So now if I talk, just like in this example I talked about, once you have the intuition and faith, you take the step. Similarly here, when you have the gradient and learning rate, you have the step and if you subtract it from the previous position and you get the new position and you keep on going. But once you reach here, what happens is gradient on this position is going to be 0
0.
because slope is 0, or you can say that the change in one quantity with respect to other quantity is 0 at this place. Okay.
Okay.
Okay, so let me see.
Could you
Yeah,
explain this equation once again? That loss and the intuition.
yeah. So they see now the this is the gradient descent algorithm equation. Okay,
Okay.
let me use C. So the x new. Now let's take the example of the what we have learned from the uh, you can say what we learned in the um, previous what we were dealing linear regression. In linear regression, we have alpha and beta, right?
Mm.
So you can say that key new alpha value is going to be old alpha. New alpha is going to be minus old alpha. Gradient, I mean learning rate. Learning rate LR into dy over dx alpha into loss. This is going to, I mean, let it be. You may end up getting confused. Let me use the x example. So suppose we have to find the optimal value of x, right?
Okay.
Wait. Oh, let me. I mean, you did not understand it, right? So let me go with the other example. So let's solve an example. In that way, you will be able to understand it better.
Okay.
So suppose this is a loss function, right?
Mm.
So y equals to x square. This is a loss function, and here you can see that. So the graph is going to
Mm.
look like this. Okay. Now suppose I am standing at this position. So initially my loss is going to be at x equals to, the loss is going to be 9. We just put 9
Mm.
here, right? Now we have to optimize it. We have to optimize the value of x such that the value of y is low, or you can say the loss is going to be low. So
Mm.
if use y equals to x square, so if the value of x equals to 3, we have value of 9. Now what we
9.
have to do, we have to optimize it. Obviously, if you look at this, you can say that the minimum value of x is going to be what? 0,
Mm.
right? Obviously, at 0, it is going to be the lowest. The value of y
Mm.
is going to be lowest, right?
Yes.
That is, I mean, that is because that is easy for us to understand, because this is a very simple cost function, right?
Mm.
So as of now, but in case of algorithm, what it is going to do is, so suppose we are at this position, or you can say that we are at this position where the value of x is 3 and the loss function is 9. Now the first thing
Mm.
that algorithm is going to do is, we are going to calculate the uh, loss with respect to x. So what we are going to do, we are going to do dy over dx. We have to calculate the gradient, or you can say slope, and this is we do by dy over dx. Now here what
Okay.
is here y is equals to x square, right?
X square. Yes.
And we have to differentiate it with respect to x.
X.
So what we are going to do here, we are going to get 2x,
2x.
right? Now we have the gradient, right?
Gradient.
We have the gradient, but it is not in numerical value,
Mm.
because 2x, right? Now
Yes.
we have to find the gradient at x equals to 3. At the
Mm.
end of the day, we have to find x equals to 3. So what we do, we put the value at equals to
X
3.
equals to 3.
So the gradient at this position is 6.
6.
Now we have the gradient. Now
Mm.
the next thing is what we have to know, the learning rate.
Mm.